All right, we're recording. So thanks again for having me at the ASQ chapter meeting. My name's Matt Bruner, and I'm one of the account executives from Machine Metrics. Machine Metrics is a software company based in Boston, Massachusetts. We'll spend a bit of time talking today about how it is we empower manufacturers with real-time machine data. I am on the sales team. I'll try to minimize the sales spin here and really just help your group develop a vision for being able to use machine data within your organization, not just to drive quality improvements, but to drive operational improvements, help ensure profitability and competitiveness within the manufacturing space. If it's looking like a technology that may be applicable within your organization, I would certainly enjoy following up and evaluating how it is we can be of further help. As Craig introduced, I come from a manufacturing background. It wasn't long ago that I was working directly in precision CNC machining, more at an operational than a quality role. But I was with an organization that was both AS 9100 certified, ISO 13485 for medical, and of course, aerospace and applications. So very familiar with some of the quality processes that it took to deliver good parts on a timely basis at a good price point for our customers. For today's agenda, what we'll be doing is running through a bit of Machine Metrics background. We'll go through a high-level overview, talk about who we are, who it is we normally work with, and the types of equipment we can connect. We'll specifically look at a variety of problems that we help manufacturers solve on a day-to-day basis. We'll look at some of the underlying technology in terms of our infrastructure, how it is we connect and make this data available. And then we'll finish with a short live look at the software itself and really help further that vision for using similar tools within your organizations. Looks like we've got a good group tonight. I see close to 35, 36 folks dialed in. Target about 45 minutes, and then let you guys get on with your Wednesday evening. Another bit of background: I am based out of Philadelphia, so I think I'm as disappointed as everyone else that we're not able to meet in person and share a good dinner through this presentation. But hopefully, in the years to come, we'll be back on track with some in-person events. So I meant to open this up with a poll question as a bit of an icebreaker. Unfortunately, I had a misstep in my use of Zoom technology here. So we're just going to have to go through this one a little bit verbally. But as we're running through this presentation, I want you guys to think about in your respective organizations, how it is you're currently using real-time data. Maybe not necessarily from a machine, but even if it's from operator entered sources, information from your QMS systems or SPC tools. Often during the sales process at Machine Metrics, we'll actually classify customers in a variety of ways. There are some that, as a starting point, they have a good grasp on exactly what's happening and how they're performing at any given point in time from, really anywhere inside or outside of the plant. These are a little more sophisticated users and tend to represent a small fraction of what we see in manufacturing. Most commonly, though, we see customers that have ERP or QMS type systems with some historical data, maybe that was entered by hand by an operator at the end of a shift or the end of a day, and they have a good grasp of what happened, say 12, 24 hours ago or maybe more. But often that data, it has gaps. It's a little too late to really take action on. And we see a lot of value in being able to really bridge that gap into real time and help the right people get the right data when they need it. And then the last group, we still see plenty of manufacturers that really don't have much data to start with. It's a guessing game. It's a gut feel that drives some of their decision making. And that is presents a lot of opportunity for improvement. So again, for today, we'll specifically be looking at how real-time manufacturing data can drive continuous improvement, not just in the quality sense, but from an efficiency perspective, helping our customers increase their machine utilization, improve customer lead times, and really align with some of the objectives in most quality management systems surrounding continuous improvements. So as I introduced a moment ago, here at Machine Metrics, we provide a machine data platform and position ourselves as the machine data component of the digital factory. There are a lot of different buzzwords we can use surrounding Industry 4.0, IoT, big data, analytics. But at the end of the day, we help our customers turn manufacturing data into actions. We do that by presenting very simple connectivity to a mix of manufacturing assets. So you could think of CNC machine tools, injection molding equipment, in some cases CMMs or vision systems. Then by offering simple connectivity, we're able to take that data and bring it into a cloud-based infrastructure for where it's all managed in a reliable fashion, one that our customers can use day in and day out, and then sync with other software systems that they may be using, like an ERP or MES. And then most importantly, we have an application layer such that our customers have out-of-the-box tools to start adding visibility and really improve communication within their manufacturing environment. And we'll look at each one of these components as the conversation progresses this evening. And guys, I will be keeping an eye on, you should see a Q&A box on your Zoom window. If you have any questions, that's a good starting point. Feel free to drop them in there. I'm also watching the chat as well to keep this as interactive as possible. So where I mentioned before, with customers kind of falling into different buckets in terms of their use of data, we often find that, at best right now, most customers are in sort of this descriptive phase of the analytics journey. Often there may be a good grasp on what happened yesterday or what's currently happening. But Machine Metrics is really a partner in helping customers undergo the full digital transformation. So we guide our customers through a journey that starts with enabling these descriptive analytics, and then taking it a few steps further, starting to uncover if there are production issues or possible bottlenecks, what are those issues? If there are maintenance issues, what are some of the underlying causes? Pushing them through, the 5 whys or the root cause analysis. And then into the future, we want to start using this machine data to not only say what's happening now, but say even what's likely to happen and help them take action to get on a course that can prevent the creation of bad product or prevent costly machine failures. Do want to highlight a sampling of some customers we're currently working with and maybe a few names that you guys recognize. We are at Machine Metrics very much focused on discrete manufacturing. So you can think of CNC machining for med device or aerospace applications or other industrial applications. We're very active in metal fabrication, injection molding, die casting. It's rare, though, that we work with process manufacturers, though there are some unique use cases in those environments. Really, though, the common denominator across our customer base is that these are groups that are heavily invested in manufacturing. They're continuing to purchase new manufacturing assets, often in the range of hundreds of thousands, if not millions of dollars. They're investing in new automation technologies and really have a strong belief in using machine data and being able to stay competitive in their space. And again, mentioned a few of the machine types we currently work with. You can add CMMs to the mix here. There are certainly others like injection molders, stamping presses, press brakes, lasers. This is not a comprehensive list by any stretch, but just want to spark some ideas for the types of equipment that we can connect within a manufacturing environment. All right, so not to be a downer here, I do want to talk about some of the challenges that we've really set out to solve. And I'll start by sharing a couple stories, and some of these may resonate with folks in your group. We just had a question pop up, so let me take a look here. Hang tight, folks. I think I may need to stop my screen share before I can look at the question. So we'll come back to this in just a moment. Um, but I want to share a story from my previous manufacturing experience. Often work orders would go out to our factory floor. By the end of the shift or end of the day, that data would be recorded. We'd see how many parts we'd produced. We'd have a count from the operators on how many bad pieces there were. And as management, in the next morning or maybe sometime that week, we'd start looking at the data and realize we'd come up short. And often that would have us asking questions. Obviously we want to figure out what some of the causes for those issues were. But in going back to our group of operators or shift supervisors, we often got mixed stories. It changed depending on who was asked a certain question. And what was universal is that we'd hear, hey, these problems are solved, we're good to go. We were able to fix this this quality issue where we're having a bad surface finish, but what's run since has been great. And then the next round of data would come through, and we'd see, hey, we just made those same mistakes again, and it didn't always add up. So what we want to do is start bridging some of that gap, and instead of asking about these issues in the prior day or a week later, see them as we're happening, and not only have the management team exposed to that information, but even operators, folks on the factory floor, help them be part of the continuous improvement processes as well. So some of these issues may resonate with your group. Just a lack of data leading to inefficiencies or a cumbersome process to get the data. Downtime that's just unexplained or not necessarily categorized. And what we've actually found by connecting thousands of machines in the field is that most manufacturers only run their equipment just shy of 25% of the time. And that's not all bad news. What it tells us is that among these very profitable and competitive companies, there's still a tremendous room for improvement. So I'll speak a little bit to also some of the challenges in starting to collect data, because it's obviously not a new concept. Folks have wanted to have immediate data for quite some time, but until now, it's been very difficult in many cases to capture. So many companies have a wide mix of machine types, often spanning different decades, different makes, models, control types, and that can make having a unified experience very difficult. Often they're time consuming to implement. They may not necessarily be ready to go out of the box. And the reason I highlight some of these is because Machine Metrics has been set up specifically to combat some of these issues. So we'll briefly touch on how it is we can help customers start using this data in a matter of hours. Our technology is designed to be plug and play, so you don't think of necessarily having cumbersome processes to get connected. That helps customers achieve quick wins and do what they do best in using this information, rather than just having a lengthy process of system integration to get up and running. We are focused, again, specifically on discrete manufacturing. And if some of these tools resonate, but maybe you're in the process space or food and beverage, there are other solutions that may specifically target those industries for similar reasons to help achieve some quick results. Another component that we won't touch on as much is connectivity to other software packages. So Machine Metrics certainly isn't designed to be a siloed system. Often we'll automate the movement of data between our platform and tools like Power BI, Tableau, systems like SAP or Oracle, really to further add value and minimizing any sort of hand data entry. All right, so I'm sure by now some of you guys are probably asking what this actually looks like. So here are a few shots, and we'll run through more of this during a short demo. But when we talk about adding real-time visibility, one of the key ways is via dashboarding and reporting, all in real time. So what you see here is a sample customer of ours. What they're doing is showing machine performance and actually OEE. So it includes a quality component, not just to management, but even to operators on the factory floor. These tools are designed to be intuitive, easy to use, And often just by adding a visualization like this and a layer of accountability for the operators, we'll see improvements in productivity anywhere from 10 to 15% in terms of OEE and machine utilization. And much of that comes by just shifting the focus from, say, a task where a machine operator may have to spend their shift from 7 a.m. to 3:30 in front of a machine looking busy. This instead shifts the focus to really maximizing the number of good parts that can be produced off of a single piece of equipment, and giving some clear goals to the operator in terms of performance. Beyond though just production monitoring, often from a quality perspective, condition monitoring can be equally as important. When we talk about condition monitoring, you can think of it a bit as process control. So enabling alerts based on machine parameters that maybe go out of a given range. So spindle loads that exceed a certain value, temperatures, sometimes these can be leading indicators of quality failures or product issues. And via the Machine Metrics platform, we can easily set up alerts via text, email, or right within our application that are going to help bring that to the attention of the folks that can take action and solve a problem really before it propagates. Similar tools too can be helpful if maybe there is some scrap that's found in a downstream process. Machine Metrics will empower users to have history to go back and find the point of time for which an issue may have occurred. On a more emerging part of our technology, we're able to learn from the data that we collect and build out machine learning algorithms that can autonomously detect potential failures. So you can see here just some sample data that reflects the load on a spindle across different cuts in a machining process. Where the failures start to occur, there's increasing variability. You don't necessarily need to be a data scientist to pick out where a process may have changed. And based on this sort of information, we can help customers predict tool failures, which can be, of course, responsible for quality issues or significant stretches of downtime on a machine. And I mentioned too the interconnectedness of the Machine Metrics platform. We empower our customers to take this data, bring it into other platforms like a QMS system. So you can really start to sync best of breed applications and have a foundation built on top of this machine data. So I'll briefly touch on how it is we connect to different types of equipment. We make it a simple process and use just a couple pieces of hardware. The first one that I'll point your attention to is this edge device. This is the green box here. What it's going to do is network to most modern PLCs, and it will use a software adapter where applicable to pull data from controls from Allen Bradley, Mitsubishi, Siemens, Heidenhain, Fanuc. It's an extensive list for which Machine Metrics is built out of the box software adapters. But where maybe we're talking about connecting legacy equipment, machinery not made for Industry 4.0 type technologies, we do have a supplemental digital and analog I/O kit. And this device can be used to pull in sensor data from a machine or tie into relays on a machine to get the appropriate information. And it enables a lot of creativity on the part of our customers. Once that data is captured at the edge, it's brought into our AWS infrastructure. Machine Metrics is a cloud-based tool. And I'd be curious, maybe a separate polling question to get a sense for how many of you guys are currently using cloud-based software as a service type options within your factories versus maybe folks that are still using on-premise type products. Obviously, there are certain reasons that would drive a choice for either. But with the Machine Metrics approach and our partnership with AWS, what we enable to our customers is a high level of scalability, a very low touch from an IT perspective solution that our customers can just trust day in and day out with 99.99+% uptime. There are also advantages where all of our customers are using the same code. So as we roll out updates or learn from one customer, we're able to deploy it customer-wide and ensure that, much like your iPhone, you wake up every morning and it's always got the latest and greatest software. If you subscribe to the automatic updates, the Machine Metrics platform will function in much the same way. And then we'll touch on just a moment some of the out-of-the-box applications. So I'll skip over this slide just for time's sake. And in closing out, I'll leave you guys with a quick case study. This particular user, not based in southeastern Pennsylvania, closer to the Midwest, is a medical device manufacturer. They deployed the Machine Metrics platform across a few hundred machines at their sites, and saw a 30% increase in OEE, really just by focusing on some basics, using machine data to start driving and being their source for understanding production and performance, understanding root causes of downtime, enabling operators to have access to the same information and really start driving continuous improvement. So I'm going to take a short pause. I see a couple questions now from Tamala. I appreciate you reaching out here. So we covered Machine Metrics being cloud-based already, and I see the other question surrounding Machine Metrics working with ERP systems. There are a few ways that we'll interface with ERPs. Machine Metrics has open APIs, so folks with basic development skills can leverage those. We also have simple imports and exports over CSV files that can just automate the movement of data between ERP and Machine Metrics on a nightly basis. It really depends on your goals for having either a unified operator interface or just minimizing redundant data entry. For certain packages too, like Epicor, Infor Visual, Job Boss, we have out-of-the-box integrations available. So I'll keep an eye out for any other questions coming through here. And then I'm going to shift focus a little bit into the product itself. Okay, I think you guys should still be seeing my screen. So what I'm starting with, guys, is one of the most common applications within the Machine Metrics product. What we'll call the current shift dashboard here is displaying performance across, in this case, 19 machines. This is all real-time data coming from one of our customers in, I believe, the Chicago area. Of course, we're visualizing it on my laptop here, but you would expect to see similar displays around their factory floor, available on smartphones, tablets, virtually anywhere in the world via a secure internet connection. What these sort of displays and visualizations are designed to do are really give immediate feedback into a machine's instantaneous status. So running, if not running, why is it not running, alarm information, setup mode tracking, and much more. And that's all displayed just at the very top portion here. The lower portion of the tile, though, is designed to be more shift oriented, in the sense that where these are displayed to operators, we want to empower them to really take action on the results that they can directly impact. So we found that keeping it focused on shift really is the best way to help them do that. Here we're tracking performance in terms of number of parts produced against an expected quantity based on this customer's either estimated cycle time or standard throughput rate. And then it's color coded based on the goal. Lastly, too, we can help customers see exactly what job is running on a given machine, as well as the number of parts produced on an hour-by-hour basis. A lot of different ways to set up these displays. This is just one sample. You get to set up different groupings. So if your factory is organized in different manufacturing cells or areas, or you start to differentiate by different machine types, you can certainly break it down in a number of different ways. I hope this strikes folks so far as being pretty intuitive and easy to understand. We really strive to present a modern interface, one that even folks that maybe aren't tech savvy can pick up on very quickly. This won't necessarily be a comprehensive demo, guys, by any stretch. Beyond the dashboards, I want to walk through our operator interface, some of the underlying data, and then we'll close out on just a couple of basic reports that you may find useful. So the next transition, I want to look at really what it is we mean by being a data platform. And this sort of visualization isn't one that our customers are going to dive into necessarily on a regular basis. But what it does is emphasize so much of our technology surrounding the ability to quickly capture data points from a given machine and then bring it into our cloud platform. So for this particular CNC machine, we have not just machine running and not running, everything from the line of code being processed, the program name, diagnostic parameters. And this is really the foundation of our IoT platform. I don't want to downplay what our developers do, but effectively we've created this architecture where building applications on top of this is now the easy part. It really helps customers make sense of this information in a meaningful way. In terms of being able to display all those data points, we empower customers to set up very simple timeline views. So if you wish to track maybe the tool that's in a cut, maybe there are different load parameters, sensor data that's coming into the mix, you can do so as a time series. And this is helpful for both that condition monitoring and process control that I mentioned before, diagnosing possible failures. So in this case, we could see for this machine at around 6:10 p.m. It was in a bar feeder emergency stop. That likely means that it ran out of material. We could see the control mode went into a manual state. So maybe the customer had to do some tool offsets with new material coming in. And then since then, it's been running consistently. And then, of course, we could also start to see individual cycle times and much more. And I do see a question coming in. For those of us working in process industries, do you have any particular recommendations? That can be tough. It's not an industry that I know as well. And often it's a combination of solutions. We see tools like Kepware kind of serving as the middleware or the connector to bring this data into other software products. But they'll handle the connectivity component. We see tools like Siemens MindSphere, PTC's ThingWorx used in some larger factory environments, but they're much less out of the box and often require a high level of customization, which is a bit of a nature around process and manufacturing. We usually see more customized than, say, an off the shelf CNC machine tool or stamping press or robotic welder that Machine Metrics might connect. But thank you for the question there, Tom. So continuing forward in the software demo component, I want to next look at our operator interface. And by operator interface, really mean kind of exactly as it sounds. This is a display that's designed to be placed right at the machine. And it can either be run on a computer at the machine, or it can potentially be run on a tablet. But ultimately, it's designed to present the operators with direct feedback into their performance. The operators can also add a layer of context to the machine data that we're collecting. And it helps our customers start to see this machine data with the additional information surrounding job and operator performance. So just to give a quick tour, this particular machine is currently running. We can see the job it's running, some basic data points here surrounding performance. And you can also see this tab display. You can think of each one of these tabs as a miniature application. And this has a lot of flexibility, such that you can even think about bringing in custom tabs, maybe that would integrate with a work instruction package where an operator can bring in blueprints. Maybe it would integrate with an SPC type tool where an operator can enter first article dimensions or their work in process inspections. there's again a lot of flexibility to help customers get the most out of this sort of package. Um, One of the key components, though, is the ability to categorize downtime or enter part rejections. So we could see here some recent categorized downtime, one that happened at 3:08 p.m. this afternoon for part inspection. And what you could think of doing, not only reporting on this data, but helping, really the operator to get help immediately rather than having to wait. This can trigger a notification via text or email to a material handler or to a quality inspector. Maybe if a part is in an inspection state for, depending on the customer, maybe more than 30 minutes or an hour, a quality supervisor might be notified, as it could indicate that there's a potential question, around the part, or maybe a more severe issue, or maybe it's just waiting on personnel bandwidth to be available to actually perform the inspection. So really what this does is simplify the resolution to downtime events. If we do need to categorize an issue, the operator will be prompted to do so in real time. But here we can categorize a historical event, just a couple of clicks. Operators can choose from a mix of user configurable categories. So if this one's down for maybe preventative maintenance, that can be entered here. And then it'll be saved alongside the machine data. The last component, I think that will interest the audience here the most, is being able to categorize some of the part rejections. There's a basic tool built within Machine Metrics such that users can enter scrap directly at the machine. So for folks that are employing quality at the source type systems, this can be a helpful tool. And much like downtime categorization, any sort of category can be applied. So maybe where this one's noting a thread error, any notes can be added. Maybe there's some issue where the threads are damaged or a no-go gauge goes. That can be added in detail, and then the rejection can be submitted. That can start to alert quality personnel. You'll also see the changes reflected on the performance dashboard. And after a short refresh here, we'll see the key performance indicators updated based on that part rejection. So the operator interface is it's an optional item. It's something though that about 80% of our customers do choose to deploy. So before we look at reporting, I'm going to check on a couple other questions here. See one from Cindy. So do you find a lot of customers who have remedial OEE knowledge, and how do you execute training those customers on how to get most out of that metric, OEE versus ATQ? So that's a good question. And, it's funny because on the sales side, we often have customers approach us because they've been tasked to implement OEE within their factory, and they find that maybe it's cumbersome, or they just don't have the underlying data to do it. Or maybe a customer is requiring that they have OEE if they're in automotive or some higher volume space. And there's often a lot of discovery to determine if OEE is even the best metric that's going to align with a customer's business objectives. So that's kind of step one, is just figuring out, hey, is OEE right for the customer, and is it going to help them solve all of their production or quality type goals. But once that's addressed, we do decide that, hey, OEE is the best path to go down. There are a few different configurations we can make, depending on how each customer interprets quality, availability, and performance. And once that's solidified, Machine Metrics has a customer success team that'll work with hands-on training. So beyond just providing support articles, we'll do workshops around OEE, helping everyone from production supervisors to executives to even operators know what's going into that metric. Because we definitely find it to be much more impactful where it's clear across the organization what this number is, rather than just chasing after it and maybe trying to maximize it without having a true understanding, where customers can very clearly articulate what OEE is going to mean to their organization. They tend to do better using that metric. But we see a lot of others around sometimes just machine utilization, maximizing uptime, maximizing throughput. Parts goal is another metric that we'll display out of the box in addition to OEE. So kind of long answer to that question, but it really starts to depend. And at the end of the day, we want to make sure if it's OEE that a customer's tracking towards, that we're able to work closely with them to understand the key components that are going to be most relevant. All right, so just to close out, I'll highlight a couple of reports, just to give you a sample for how some of the historical info might be beneficial, or at least have it at the fingertips of your teams. So I'll just start with some basics like tracking machine utilization. Often this can be a helpful number for maybe the customers that aren't quite ready for OEE. So if we look at this particular manufacturing company, maybe we want to look at just first and second shift performance. Here I've pulled in data across the last 6 months, and we're breaking it down by week. What we can do is start to identify different trends. So where customers may have some sort of continuous improvement type goals, this can be a helpful place for seeing how they're tracking towards those different efforts. So if they're investing in other technologies, maybe they're purchasing new equipment or adding some automation. Here they can have a quick visual. Hey, we saw where this helped, or if for some reason they're going in the other direction, maybe recognize that sooner rather than later. Utilization too can also be a good way for customers to start, identifying capacity constraints, maybe having some sort of benchmark for when it is they might want to purchase new capital equipment to help support growth. And a lot of ways to break this out by different machines, different machine groupings, and more. The next item that we'll look at together comes in the form of downtime reporting. And this really helps customers, often where they see, hey, we're not at 100% machine utilization. Well, what are the key reasons for that? Here, if we want to look at, say, this particular user's top reasons for machine downtime over the last month, we can quickly develop a downtime Pareto. Maybe again, we want to look at just first and second shift, our primary production hours. And we can quickly start to see that, in this case, for instance, unplanned maintenance accounted for 1 week and close to 3.5 days worth of downtime. Obviously, we want to help mitigate this from adding up in the first place, but as it does, customers can start to act on real information when it comes to their next engineering project or their next capital expenditure. So maybe here, for instance, where part inspection is adding up to almost 3 days of machine downtime a month, maybe that would help justify the purchase of an extra CMM or vision system for this particular user. Could also start to drill down, see it broken out by machine. Any notes that maybe an operator might have left will surface here as well. Continuing to move through the product, the last one I want to touch on is a production report builder. And the reason I'm going to end here, this is a very flexible tool. I think it may spark some different ideas for how folks can uncover insights from the underlying data. And what we often find is that because Machine Metrics is built in an easy to use web interface, it's a little less I'd say challenging in many cases to uncover some of the data compared to customers' experience with either legacy systems or ERPs. And this can help everyone from supervisors to quality managers to executives, really have access to the same information. And we like to use the word democratize the production and machine data. It's not just in the hands of a shift supervisor any longer. This is something that everyone in the organization will have access to. So let's say, for instance, we just want to look at last week's performance, and of interest here is maybe seeing each machine's performance and each job that ran on that machine. Maybe we want to look at time and cycle utilization rates. Just pulling in a few metrics here. We can look at quality, good parts, parts rejected. Just add our actual part time expected. And then very quickly, we can build out a report. We can save similar reports, share them with colleagues in an easy to use fashion. So here, what we can see, if we break out each individual machine, we can see the different utilization rates. We can see how long a particular job ran on a given machine, the number of good parts produced, any parts that were rejected. Here, unfortunately, the demo environment I've got today, they're using an external quality management system, so they don't enter their scrap directly in machine metrics. But we've worked with them to build some other custom reporting within Power BI that syncs those data sources. Another interesting data point that can surface here is actual part time versus expected. And this is something that can often be an indicator of possible process changes. So if a customer has run, let's say job 00368 dozens of times, and they've solidified it as an 18-second part, and we find that on this particular work order, it's running at 20 seconds, that may mean that there was a change to the program, or maybe they couldn't find the right tool for the job, so made an edit that slowed it down a little bit. So just a few things to be mindful of. I see, Bill, you've added a question. Does your analysis include the creation of SPC charts as opposed to simple run charts? Generally, the charts and reports within the application layer that we're highlighting here are going to be on the simple end of the spectrum. These are tools that all of our customers have access to. Often we find that SPC charts are a little more tailored to certain production processes. And that's usually where we'll have some sort of external reporting. Maybe it's by syncing it with an Excel workbook or Power BI or even another QMS system to go the route of SPC. So I don't want to say that we can't get to the SPC information. Generally, on when it's on the out of the box application layer, it's going to be on the simple end of the spectrum. So good question. And really, guys, I think that does it for me in terms of the quick product tour, the presentation. Do want to spend the remaining minutes here answering any further questions. Everyone too has been granted permission to speak. If anyone feels like unmuting and raising a question verbally, happy to open up the discussion. All right, so radio silence so far. We'll hang out for a few more minutes. What I can do is stop the recording. Maybe that'll open up some more willingness for the general Q&A and discussion. Folks need to jump off. Appreciate everyone who's listened in so far, and shout out to Bill Gordon for inviting me today, reaching out to my colleague Graham, and helping us get set up.